Okay, I want you to picture something. The date is July 6th, 1885. It's a sweltering summer day in Paris.
Right.
And you're in this cluttered laboratory. It smells of, chemicals and gas burners.
Mm-hmm.
And in the middle of this room, there's a man. He's one of the most famous scientists in France. A celebrity, really. But right now you can see he's absolutely terrified.
The tension in that room must have been just suffocating. That man is Louis Pasteur, and standing in front of him is this little 9-year-old boy. His name is Joseph Meister.
And this boy, Joseph, is in catastrophic shape.
Catastrophic is putting it mildly. He'd been attacked by a rabid dog.
Yeah, and we're not talking about a little nip on the ankle.
Yeah.
He was bitten 14 times, all over. His hands, his legs, deep, ragged wounds just soaked in the dog's saliva.
And you have to understand, in 1885, that is not just an injury. It is a guaranteed death sentence. Rabies was probably the most feared disease in the world.
A good reason.
Absolutely. Once the symptoms started, the hydrophobia, the fear of water, the spasms, the madness, it was 100% fatal. There was no cure, no treatment, just this slow, agonizing, horrific end.
So this is where the stakes get just impossibly high. Pasteur is looking at this doomed child, and he's holding a small vial.
Uh-huh.
And inside it is the dried spinal cord of a rabbit. He thinks, he believes, he has a cure. But here's the massive problem. Pasteur is a chemist.
Right. He is not a mental doctor.
Not at all. He has no license. So if he injects this boy, if he practices medicine, and the boy dies, which is what everyone on Earth expects to happen.
He could be prosecuted. Manslaughter, practicing without a license. He could lose his freedom, his reputation, everything he had spent his life building.
But if he does nothing, the boy dies anyway. It's an impossible choice. Do you risk your entire legacy, your entire life's work, on a completely unproven theory to save one child?
It was the ultimate crossing the Rubicon moment for him. But, to understand why he was even standing there with that vial with that dried rabbit spinal cord in his hand.
And why he was the only person on the planet who could maybe save that boy.
Exactly. To get that, we have to rewind the tape. Because that single moment was really the culmination of an entire lifetime of obsession, of tragedy, and of just refusing to accept the world as it was.
So today, we are doing a deep dive into the entire life of Louis Pasteur. And I think for most of us, myself included before this, you hear the name Pasteur and you think one thing.
Milk.
Milk. The carton in your fridge. Pasteurization.
Yeah.
But as we went through all the research for this, it became so clear that the milk is like the least interesting part of his story. We're talking about a man who fundamentally changed the human relationship with disease and death.
It is not an exaggeration to say he's probably the most significant scientist of the 19th century, maybe, top 5 in all of history.
That's a huge claim.
But think about it. Before Pasteur, medicine was largely guesswork. It was humors, miasmas, bad air. He didn't just discover things, he founded entire fields of science from scratch. Crystallography, for one. Microbiology. Immunology. These are the absolute pillars of modern science, and he basically laid the foundation stones for all of them.
And the story of his life is just wild. He wasn't some born genius. He was considered a mediocre student. He dealt with immense tragedy and even, quite literally, paralysis. So our mission today is to trace that arc. How does an average art student become the man who proved that invisible monsters are real?
And it all starts in a place you would never, ever expect. Not in some fancy Parisian lab, but in a smelly, dirty tannery in a small French town called Dole.
This is December 27th, 1822. Louis is born.
Yeah.
His father is Jean-Joseph Pasteur, and, well, tanner is a polite word for it.
It's a rough job. His dad worked with animal hides, harsh chemicals, dead skin all day long. They were poor, but his father had been a sergeant in Napoleon's army.
Oh, interesting.
Yeah, fierce patriot. And he drilled this sense of discipline and honor and the glory of France into young Louis. But the funny thing is, Louis didn't care about any of that. He didn't care about science. He wanted to draw.
This was my favorite surprise from the research. Teenage Louis Pasteur wasn't in a lab. He was an artist. He was making pastel portraits.
And he was good, like really good. We aren't talking about little doodles here. He did these incredible, hyper-realistic charcoal and pastel portraits of his parents, his neighbors.
And you can still see them today. They're amazing.
They are. And this is actually crucial. This wasn't a waste of time. He trained his eye. He learned how to observe the world with meticulous detail to see what was really there, not what he thought should be there. That skill is what made him a great scientist.
Okay, so he's a talented artist, but what about his schoolwork?
Average.
Yeah.
Genuinely. One of his teachers at the college in Besançon actually described him as slow.
Slow. The man who saved millions of lives was called slow.
Well, he was methodical. He never, ever affirmed anything until he was absolutely certain he understood it from every angle. And, there's some fascinating modern analysis that suggests Pasteur might have had dyslexia and dysgraphia.
Ah, that would make sense. In a system that relies on reading and writing quickly, he'd seem slow.
Precisely. It was a struggle for him to get into the École Normale Supérieure in Paris, which was, the MIT or Harvard of France. He took the entrance exam the first time and ranked 14th.
Which, for a poor tanner's son, sounds pretty great to me.
You'd think so. Most people would have celebrated. Pasteur was so disappointed he refused his admission.
She turned it down.
Said 14th wasn't good enough. He went back, studied for another full year, retook the exam, and got in ranked 3rd. That tells you everything you need to know about his personality. Stubborn, perfectionist, just relentless.
So he finally gets in, he studies chemistry. And his first big discovery, the one that puts him on the scientific map, it has nothing to do with germs or medicine or saving lives. It's about crystals.
Crystallography. And I know that sounds incredibly dry, but you have to stick with us here because this is the key that unlocks his entire career. This is the moment he bridges the gap from the non-living to the living world.
Okay, so set the scene for us. It's 1848. He's young, just 26 years old.
Right. And the scientific world has this little puzzle they can't solve. It involves something called tartaric acid. It's a chemical you find in the gunk at the bottom of wine barrels.
Okay.
Now, scientists knew that this natural tartaric acid, when dissolved in water, did something weird to light. If you shone a beam of polarized light through it, the light beam would actually rotate. It would twist to the right.
And that was just a known property of it.
A known mysterious property. But here's the puzzle. There was a synthetic version made in a lab called paratartaric acid. Chemically, it was 100% identical. Same atoms, same formula, same everything. But it didn't twist light at all. It was optically inactive. And nobody could figure it out. How could two things that are chemically identical behave so differently? It broke the rules of chemistry.
It's like having two identical twins, but one can sing and the other's mute.
Perfect analogy. So Pasteur, with that artist's eye of his, looks at the crystals of this stuff under a microscope, and he sees something everyone else had missed. Tiny little facets, tiny flat faces on the corners of the crystals. A detail.
A tiny detail. And he realizes that in the synthetic stuff, the stuff that didn't twist light, there were actually two different types of crystals mixed together.
Two types.
Yes. One type had this little facet on its right-hand side. The other type had the facet on its left-hand side. They were perfect mirror images of each other.
Like your left and right hands.
Exactly like your left and right hands. They're the same, but they're opposites. You can't superimpose them. That's chirality or handedness.
So what did he do?
This is the painstaking part. He sits down with a pair of tweezers and a dissecting needle, and for hours and hours, he manually separates these microscopic crystals into two piles, a left-handed pile and a right-handed pile.
That's insane dedication.
It's pure Pasteur.
Yeah.
So he's got his two piles. He dissolves the right-handed pile in water, shines the light through it, and it twists the light to the right.
Okay.
Then he dissolves the left-handed pile, shines the light, and it twists to the left by the exact same amount.
So when they were mixed together, they just canceled each other out. Precisely. He had solved the puzzle. He discovered that molecules aren't just a list of ingredients. They have a three-dimensional shape, a geometry. And that was a massive leap for chemistry.
But I'm still trying to see the link. How does this get us from wine crystals to germ theory?
This is the big insight, the leap of genius. Pasteur looked at this and he had this profound realization. He noticed that in the non-living world, the mineral world, you almost always find both left and right-handed forms together. They're symmetrical.
Like in a synthetic acid.
Exactly. But these asymmetrical or handed molecules, they only seem to come from living things, from grapes, from fermentation, from life processes. And he concluded that this asymmetry, this handedness, was the fundamental dividing line between life and non-life. It was the chemical signature of a biological process.
Wow. So he found a chemical footprint that only life could leave.
He did, and that idea that life has a specific, measurable chemical effect on the world is what dragged him out of the tidy world of pure chemistry and into the messy, chaotic, and frankly much more important world of biology.
Which brings us to the fermentation wars. And I love that it's called that because it really was a scientific brawl.
Oh, it was a knockdown, drag-out fight. So in 1854, Pasteur gets a new job. He's made professor and dean of sciences at the University of Lille. It's a big industrial town in northern France.
And he's not an ivory tower kind of guy.
Not at all. He tells his students right away, we are not just staying in the classroom. He starts taking them on field trips to factories, to foundries. He wants science to solve real-world practical problems.
And a very real problem walks right through his door. A man named Monsieur Bigot.
Right. Bigot is a local industrialist, and his business is making alcohol from beetroot juice. It's a huge industry there. But he's in the middle of a crisis. Some of his giant fermentation vats are working perfectly, producing good alcohol, but others are going sour.
Sour.
Yeah, they're turning into this slimy, acidic mess, lactic acid instead of alcohol. And he's losing a fortune. He has no idea why.
So at this point in history, what do the top scientists believe fermentation even was?
The prevailing theory from giants of chemistry like Justus von Liebig in Germany was that it was purely a chemical process, that it was just decomposition. They believed yeast was just a complex chemical, and as it died and fell apart, it broke the sugar down into alcohol. There was nothing alive about it.
It was just dead stuff causing a chemical reaction.
Exactly. So Pasteur takes samples from Bigot's vats back to his lab. He puts a drop from the healthy vat, the one making good alcohol, under his microscope. And what does he see?
Yeast cells.
Yep.
Yeah.
These little round, plump globules of yeast budding and growing. Then he takes a drop from the sick vat, the sour one. The yeast is gone. Instead, the liquid is swarming with these tiny black rod-shaped things, much smaller than the yeast cells.
Bacteria.
He didn't have that word for them yet. He called them ferments, but yes, it was bacteria. And he had another one of those huge insights. He realized these things were alive, and they were competing. The yeast was a living organism that ate sugar and, let's say, produced alcohol. And these little rods were a different living organism that also ate sugar but produced lactic acid instead. It wasn't chemistry, it was biology. It was a battle of microbes.
So the sickness of the wine was literally an infection.
Fermentation is life without air, was his famous declaration. It was a seismic shift. And you can see the next logical step, right? If a sickness in a vat of beet juice is caused by a bad microbe invading the system, could a sickness in a human body be the exact same thing?
The germ theory of disease is born right there, on that microscope slide. But before he could even get to that, he had to fight an even bigger intellectual battle.
Oh, yeah. The big boss fight. Spontaneous generation.
This is one of those ideas that sounds completely insane to us now.
It does, but you have to give him some credit. For thousands of years, very intelligent people believed that life could just arise from non-living matter. It was based on observation. You leave a piece of meat out on the counter, and a few days later, what do you have? Maggots. Therefore, the meat must have created the maggots. You leave broth out, it gets cloudy and moldy. Therefore, the broth created the microbes.
It was what they could see. It was their observable fact.
Exactly. And Pasteur came along and said, no, that is completely wrong. The life doesn't come from the meat or the broth. It comes from the outside. It's floating in the dust. It's in the air all around us.
A pretty radical idea.
Yeah.
But he had to prove it. And the experiment he designed to do it is, I think, one of the most beautiful and elegant in the entire history of science.
The swan neck flask experiment. It's brilliant in its simplicity.
So walk us through it. What did he do?
Okay. He takes a regular glass flask and puts some nutrient broth in it, like a sugary soup that microbes love. Then he boils the broth.
To kill anything that might already be in there.
Exactly, to sterilize it. But here's the clever part. While the glass is still hot, he heats the long, thin neck of the flask and uses tools to bend and stretch it into a long, drooping S-curve.
Like the neck of a swan.
Precisely. Now, the crucial thing here is that the flask is still open to the air. He didn't seal it off. His opponents could have said, well, you cut off the vital force in the air, but air could still get in.
But the dust couldn't.
That's the genius of it. Dust and the microbes riding on it is heavier than air. So as it drifted into the neck of the flask, gravity would pull it down and it would get trapped in the bottom of that first curve. It could never travel all the way up and over the second curve to get into the broth.
And the broth stayed clear.
Perfectly clear and sterile for months. Years even. I believe some of his original flasks are still on display at the Pasteur Institute, and the broth is still sterile over 150 years later.
That is just, it's mind-blowing.
And then for the final mic drop, he would take one of these sterile flasks in front of an audience at the Sorbonne. He'd show them it was still clear. Then he would simply tip the flask just enough so that the sterile broth washed down into that first curve where the dust was trapped, and then he'd tip it back,
letting the microbes in.
letting them in,
Yeah.
and within a day or two, the clear broth would be a cloudy, swarming mess of life.
Game over for spontaneous generation.
Absolutely. He proved, beyond any doubt, that life only comes from life. The air is filled with these invisible, living things.
So at this point, he's overturned a fundamental principle of chemistry with chirality. He's figured out fermentation. He's disproved a 2,000-year-old theory of biology. You'd think the man would take a vacation.
Not a chance. The next decade, the 1860s, was a period of just frantic, nonstop work, but it was also a time of incredible personal darkness for him.
This is when he starts saving entire French industries.
It is. First, the emperor himself, Napoleon III, asked Pasteur to save the French wine industry. It was the same problem as the beet juice, just on a national scale. French wine was spoiling on the long sea voyages to export markets like England.
And he knew the culprits were these unwanted microbes, so he just had to find a way to kill them.
Right. But you can't just boil a fine Bordeaux or Burgundy. You'll completely destroy the flavor and aroma. So through careful experimentation, he discovered the perfect balance. If you gently heat the wine to about 55 to 60 degrees Celsius, that's about 135 Fahrenheit, for just a few minutes.
It kills the bacteria that cause it to sour.
But it leaves the delicate flavor compounds and the yeast completely unharmed.
Pasteurization.
He patented the process in 1865, and ironically, it was first applied to wine and vinegar. It wasn't used on milk for decades. But he saved the French wine economy, and no sooner had he done that, he got an urgent call to go south to save the silk industry.
I didn't realize how critical silk was to the French economy.
Oh, it was massive. Entire regions in the south, like the Cevennes, depended on it. But their silkworms were dying from a mysterious plague. They called it pébrine. The wombs would get covered in these little black pepper-like spots. They'd stop eating and just wither away. The regional economy was on the brink of total collapse.
So Pasteur, who knows nothing about silkworms, basically packs his bags and moves there. He ends up spending 5 years of his life studying worms.
He does, and this is where the story takes a tragic turn. We have to pause on the science for a moment because what happens to him personally during this period defines the rest of his life.
Right.
While he is down south, completely obsessed with this silkworm disease, he gets word that his father has died. Soon after that, his 9-year-old daughter, Jeanne, dies of typhoid fever.
Oh, no.
2 years later, his daughter Cécile dies, also of typhoid. She was 12. And the year after that, his youngest, Camille, dies of a liver tumor at age 2.
My God. 3 of his children.
3 daughters, gone in the space of just a few years, all but one to infectious diseases. Can you imagine the psychological state of this man? He's looking through a microscope every day trying to stop an invisible plague in worms while another invisible plague is wiping out his own family.
It must have felt like he was at war.
It was a war. It became personal. He developed this deep, visceral hatred of disease. He wasn't just a curious scientist anymore. He was a soldier, and he was fighting an enemy that had taken his own children from him. The stress was just immense.
And his body broke down.
In 1868, at only 45 years old, he suffers a massive cerebral hemorrhage, a huge stroke.
At 45, that's so young.
It paralyzed the entire left side of his body. For the rest of his life, his left arm was basically useless, rigid at his side, and he dragged his left leg when he walked.
Most people would have retired. They would have said, I've done enough.
But this is Pasteur. That wasn't in his DNA. He refused to stop. From his sickbed, he dictated notes and instructions to his wife, Marie, who became his most essential assistant. He directed the rest of the silkworm project from his chair.
And he solved it, even after the stroke.
He solved it. He identified the microscopic parasite that was causing the disease. And then he did something amazing. He taught the local breeders, these were simple, uneducated farmers, how to use microscopes themselves. He developed a system where they would crush the female moth after she laid her eggs, examine a drop of her tissue, and if they saw the shiny little corpuscles of the parasite, they would destroy that batch of eggs. If she was clean, the eggs were safe.
He turned an entire generation of farmers into microbiologists.
He saved their industry. But more importantly, he had established the principle that a specific microbe causes a specific disease. This was the final piece of the puzzle he needed before he could turn his full attention to human medicine.
Which brings us to part 4, germ theory, and the birth of vaccines. And we should probably give a quick nod here to Joseph Lister.
Yes, absolutely. Lister was a British surgeon in Scotland, and he reads Pasteur's papers on fermentation and the swan neck flasks. And he has this brilliant insight.
Who connects the dots?
He connects the dots. He thinks, wait a minute, if invisible germs in the air can cause wine to rot, maybe those same germs getting into a wound during surgery are what cause it to rot, to get infected.
It seems so obvious to us now.
But it was revolutionary then. Surgeons used to operate in their street clothes with unwashed hands. Lister starts spraying carbolic acid and antiseptic over the wound and on his instruments, and suddenly his patients stop dying of infection. Surgical survival rates just skyrocket.
So Pasteur's theory is already saving lives in hospitals. But Pasteur himself wants to go a step further. He doesn't just want to treat the infection. He wants to prevent it from ever starting. He wants immunity.
And this leads to one of the most famous stories in science, the happy accident with chicken cholera.
Right. It's 1879. His lab is now working with a really nasty bacteria. It kills chickens, usually within 24 hours of infection. It's incredibly virulent.
And one summer, his assistant is supposed to inject a new batch of chickens before the lab closes for vacation. But he forgets.
So the culture of the bacteria is just left out.
Just left sitting on a lab bench for a month, exposed to the air and the summer heat. When they get back from vacation, Pasteur is annoyed, but says, use it anyway, let's not waste it. So they inject the chickens with this month-old culture.
Expecting them all to be dead by the next day.
Exactly. But the next day, the chickens are fine, maybe a little droopy, a bit off their food, but they quickly recover. They don't die.
So Pasteur thinks the culture just went bad.
He thinks it's useless. So he grows a fresh, brand new, fully lethal batch of the cholera bacteria. And to test it, he injects it into a new group of chickens and also into the chickens that had survived the old batch.
And this is the eureka moment.
This is it. The new chickens all die within a day. But the chickens that had gotten the spoiled culture before, they are completely fine, totally healthy. They don't even get sick. They're immune.
So he realizes what happened.
He realizes that living the bacteria out in the open air had attenuated it. It had weakened it. The bacteria was still alive enough to trigger the chicken's immune system to create defenses, but it was too weak to actually kill the host.
He figured out how to manufacture a vaccine. This wasn't like Jenner with smallpox, which was sort of a lucky fluke of nature using cowpox. Pasteur realized you could take any deadly germ, weaken it artificially in the lab, and turn it into a life-saving vaccine.
He called the process vaccination in honor of Genervaca being Latin for cow, but he knew he could apply this principle to any infectious disease, and he needed a big public stage to prove it to a skeptical world.
Enter anthrax.
Anthrax, the scourge of farmers. It was a horrible disease, wiping out entire herds of sheep and cattle.
So Pasteur develops a vaccine for it, using heat this time to attenuate the bacteria. But the medical and veterinary establishment is still very skeptical.
Deeply skeptical. A veterinarian named Rossignol publicly challenges him. He basically says, this is all talk. Let's have a public trial. Put your money where your mouth is.
The great experiment in Coué-Lefort.
Yeah.
And this wasn't some quiet lab test. This was a media spectacle.
It was the scientific event of the year, May of 1881. Journalists, politicians, farmers, they all gather at this farm. They line up 50 sheep. Pasteur vaccinates 25 of them with his new attenuated anthrax vaccine. The other 25 get nothing. They're the control group. Then, a few weeks later, they come back and inject all 50 sheep with a fully lethal dose of live anthrax bacteria.
The amount of self-belief that must have taken. If he fails here, in front of everyone, he's not just wrong, he's a laughingstock. His career is ruined.
He knew the stakes. He barely slept. So the day of the results, June 2nd, a huge crowd gathers. It's incredibly dramatic. They walk over to the enclosure with the 25 unvaccinated sheep.
Yeah.
It's a massacre. They're all dead or dying, bloated, bleeding from the nose and mouth. It's a horrific sight. The crowd goes silent. Then they walk over to the other enclosure, the one with the 25 vaccinated sheep.
And they're just munching on grass.
Munching on grass, perfectly healthy, not a single one is sick. The crowd just erupts. They carry Pasteur on their shoulders in triumph. It was a total, undeniable victory. He was a global celebrity, a rock star of science. He had proven that humanity did not have to be the helpless victim of these diseases. We could fight back.
But there was still one monster left to conquer. The biggest, most feared of them all. The one we started with. Rabies.
This was the final frontier for him, and it was by far the most difficult challenge of his career. Because unlike anthrax or cholera, he couldn't see the germ that caused rabies.
Because it's a virus.
Exactly. But they didn't know what a virus was. It was an entity too small to be seen by any microscope of that era. He spent months searching, looking at samples from rabid dogs, and found nothing. He called it an invisible microbe. He was literally fighting a ghost.
So how do you attenuate a ghost?
Pure genius and ingenuity. He knew the disease attacked the brain and the spinal cord, so he reasoned the germ must be concentrated there. He couldn't grow it in a petri dish, so he used rabbits as living incubators. He'd infect a rabbit, wait for it to die, and then aseptically remove its spinal cord.
Yeah.
Then he came up with this brilliant idea. He would suspend the infected spinal cords in sterile glass jars with a chemical that absorbed moisture. He would let them dry out.
Desiccation.
Right. And he found that the longer the cord dried, the weaker the virus in it became. A spinal cord dried for 14 days was essentially harmless. A cord dried for only 1 day was still incredibly deadly. He had created a graded series of potencies.
So he could create a vaccine by injecting an animal with the 14-day cord, then the 13-day, and so on, building up their immunity slowly.
That was the theory. And he tested it on dogs. It worked perfectly. He could take a dog, give it the full series of injections, and then inject it with the deadliest rabies imaginable, and the dog would be fine. He had a kennel full of immune dogs.
But making the leap from a dog to a human child,
Yeah.
that's a completely different ethical universe.
And he was terrified of it. He wrote in his notebooks about his anguish. He knew he had a cure, but he was afraid to use it. He wasn't a doctor. What if he killed someone? He hesitated until Joseph Meister showed up at his lab.
So let's go back to that moment. July 6, 1885. The boy, bitten 14 times, certain to die.
Pasteur doesn't make the decision alone. He calls in 2 respected physicians, Dr. Grancher and Dr. Vulpian. They examine the boy's horrific wounds, and they give Pasteur the green light. They tell him, look, this boy is dead already. If you don't do this, he dies one of the worst deaths imaginable. Morally, you have to try.
So the treatment begins.
It was a 13-injection course over 10 days. They started with the weakest material, the 14-day-old cord. The boy had no reaction. Then the next day, the 13-day cord. Each day, the injection was a little stronger, a little more dangerous.
Pasteur must have been a nervous wreck.
He wrote that he couldn't sleep at night. He had nightmares of the boy developing rabies because of his treatment. As they got to the final injections, using cords that had only been dried for a day or two, the tension was unbearable. The final shot was from a cord that was almost fully virulent. It could easily kill a healthy animal.
And the result?
Joseph Meister was fine. He played with the rabbits and guinea pigs in the lab. He was a little bored of all the shots, but he never, ever developed a single symptom of rabies. He went home healthy. Pasteur had done it.
He had tamed the untamable disease.
It was a global sensation. The news spread like wildfire. People started flocking to Paris from all over the world. There was a famous case of 19 Russian peasants who had been mauled by a rabid wolf. They made a desperate journey across Europe to get the Pasteur treatment.
And he saved them.
He saved 16 of the 19. It was a miracle. The Tsar of Russia was so grateful he sent Pasteur a diamond-encrusted cross and 100,000 francs.
And that money, it didn't go into his pocket. It went into building the Institut Pasteur.
Yes. An international fundraising campaign was launched. And it wasn't just governments and czars. Donations poured in from ordinary people, poor policemen, postmen. The institute was founded in 1888, built by the people of the world, for the people of the world. It became this beacon of scientific research.
But Pasteur himself, he didn't get to enjoy his status as a living legend for very long, did he?
No. His health, which had been fragile since the stroke, began to decline rapidly. He had more strokes. He passed away on September 28, 1895. He was 72.
I read about his burial. The French government offered him the highest honor, a state funeral and burial in the Pantheon, alongside heroes like Voltaire and Victor Hugo.
They did. It's the French equivalent of being buried at Arlington National Cemetery. But his family refused. They said he wouldn't have wanted that. He belonged to science.
So where is he buried?
They built a beautiful crypt for him in the basement of the Pasteur Institute itself. It's stunning. The walls and ceilings are covered in these gorgeous Byzantine-style gold mosaics depicting all of his discoveries.
The crystals, the silkworms.
The sheep, the chickens, the rabid dogs being tamed. He is literally buried within the foundation of his life's work.
What a legacy. You know, we've talked about him as this scientific hero. But he wasn't a saint, was he? He had his flaws.
Oh, not at all. He was described as authoritarian, secretive, and intensely ambitious. He had a fierce rivalry with the German scientist Robert Koch, which was fueled by the Franco-Prussian War. And he wasn't always great at giving credit to his predecessors.
Right. But at the end of the day, the impact is just undeniable.
It's hard to even quantify. We live in a world that Louis Pasteur built. Every time you drink a glass of milk and don't get tuberculosis, that's Pasteur. Every time you get a vaccine, that's his legacy. Every time a surgeon scrubs their hands before an operation, that's because of his germ theory.
He didn't just find cures. He changed the entire way humanity understands its place in the world. He proved that this invisible world of microbes dictates so much of our visible world, from industry to health.
He took the terror out of the unknown and replaced it with a process of discovery. He showed us that these microscopic monsters could be understood, and if they could be understood, they could be defeated.
There's that famous quote of his that I think just sums up his entire approach. Chance favors only the prepared mind.
I love that quote. It's so true. He wasn't just lucky to notice the crystal asymmetry or to have that chicken cholera culture spoil. Thousands of people could have seen those things and dismissed them. But his mind was prepared, through decades of meticulous observation, to see the significance of the anomaly. He was always looking for the pattern.
It's just so fascinating to me that he wasn't a doctor. He was a chemist, an artist even. And yet, he arguably saved more lives than any physician in history.
And that, I think, leaves us with a really provocative thought. What are the massive, seemingly unsolvable problems we face today? Climate change, Alzheimer's, energy crises, that we're failing to solve simply because we're looking at them through the same old disciplinary lens. Maybe the next great breakthrough won't come from the established experts in the field. Maybe it's just waiting for someone from a completely different background, an artist with a microscope, to see the one tiny detail that everyone else has missed.
That is a powerful thought to end on.
Yeah.
If this story inspired you, if you want to keep exploring the lives of the titans who shaped our modern world, make sure you subscribe to the History Titans channel.
We have so many more of these deep dives planned.
Absolutely. Yeah. Go ahead and hit that like button. It really helps the channel out. Share this with a friend who you think needs a dose of inspiration and resilience today. And let us know in the comments, which historical giant should we tackle next? Thanks for listening.
We'll see you next time.